This is the HP Spectre X360 laptop, tablet, convertible, whatever. It sports a zippy 4-core Intel 1165 G7 processor. Yeah, that's Tiger Lake U, and that launched in Q4 of 2020. It's got 16 gigabytes of memory, a gorgeous 4K display. It's got pen input, USB-A, and 2 USB Type-C. It feels built like a brick, and you should check this thing out if, you know, the specs of this laptop are ticking the boxes of something that you're looking for in a laptop. Now, what caught my attention was the second generation Intel H20 SSD. That's an SSD that contains Intel Optane storage and NAND flash. Listen, Optane is so advanced it might as well be technology left by space aliens for human beings to reverse engineer. What do you know? And of course the regular old NAND part of it, which is just what you'd find in an ordinary SSD. NAND flash. I mean, that's pretty much in every other machine on planet Earth, because nobody wants to deal with mechanical hard drives anymore, at least not for productivity machines. Now, I reached out to Intel to ask about the H20, and they sent this to back up their claims about performance. And you won't believe what I found. Let's do a deep dive. So first, let's take a look at the H20. It's an M.2 SSD that combines NAND flash and an Optane. Literally. Optane M.2, NAND flash M.2. One device. It takes two products, the Intel 670p, I mean, not really, they don't really say that, it just sort of tests like that, and the 32 gig Optane. And again, they don't really say that, it just sort of tests like that. And they put it on one M.2. It's the successor to the H10, which is the first time they did this, I think, which similarly combined Optane and flash. And at that time, the H10 kind of tested like the 660p when you were testing the NAND flash part of it. But what you might not realize is that both the H10 and the H20 actually show up as two separate devices. It's just like you got an M.2 splitter and plugged both of these into one M.2 slot. Now the reality is that they're both on a single SSD, and they show up as two different SSDs. This is a big contrast to other devices we've reviewed, like the Inmodus Fuse drive, where it's got one big block of SLC cache at the beginning, single level cells. Those run really fast, and they're at the beginning of the drive. But it doesn't show up as two separate PCIe devices. You just sort of have to plan for that as you're dealing with the drive. And other drives use other more advanced algorithms to sort of figure that out. So now in terms of downsides, that means that each half of the device only has two PCI Express 3 lanes to work with. The Optane side gets two PCI Express 3.0 lanes, and the NAND flash gets two PCI Express 3.0 lanes. And yet, Intel claims the device can top out at 3.3 gigabytes per second. How can that be possible? That's suspect, isn't it? That's a suspect claim. How would you even be able to do that? It turns out it can, and it's magic, and it's really interesting, but more on that in a sec. For the NAND flash side of the device, it looks like Intel has learned some things, which is great, because back when I took a look at the H10, I thought it compared pretty well to, you know, just sort of DIYing it, especially compared pretty well to just pure NAND-based devices. But I also thought that the performance characteristics were like the 660p. And the 660p wasn't a bad product, it's just that Intel left a lot of performance on the table, in my opinion, because it wasn't really competitive with even really sketchy SSDs out of China. You know, but the 660p was pretty affordable flash and the Intel build quality. And paying for Intel build quality, I mean, that's nice most of the time. There are downsides of the 660p. That was apparent that Intel really didn't do any firmware optimization on it, so it led to certain performance anomalies. Like if you were doing something really write-heavy, the SSD could sort of bog down, even when you just wanted to do reads. It seemed like the firmware should prioritize reads because you can always read from flash pretty quickly, even when you're kind of write busy, but it didn't seem like it really tried to deal with that. So it really left a lot on the table in terms of performance. I think pretty much everybody agreed about that when I took a look at it. But it was a neat device, you know, Optane and NAND flash on one device. So I was a bit disappointed to learn that the H20 is still the same sort of split design, the H10, two PCIe lanes for the flash device and two PCIe lanes for the Optane device. I mean, it does open the door for better cross-platform features. Like you can use an H10 or an H20 with LVM on Linux. You can use it as an LVM block cache. It works fine. It works exactly the same as if you used 2 separate devices. And I got news for you, this device is not going to bottleneck 4 lanes of PCI Express 3.0, let me tell you. But this one gets close. So it is nice having 2 separate devices for cross-platform compatibility. On the Linux side, you could also use Optane as kind of a high-endurance write cache, because it's still really, really good in terms of the endurance characteristics. So yeah, I mean, if you do that, you might bottleneck some things, but it's probably okay. PCI Express 2, for that terabyte of NAND flash, yeah, that's going to bottleneck a little bit. I mean, that's true in the benchmarks, but real world, as I found testing this in a desktop scenario or a laptop scenario, it's not necessarily actually true from a practical standpoint. So I really thought the H20 would be an incremental upgrade over the H10. I mean, how big of a deal can it be with a measly 32 gigabytes of Optane for cache? I mean, I'm a power user. 32 gigabytes is not enough. And at 3.3 gigabytes per second, this thing will run out of cache in 10 seconds. That doesn't seem like a lot. Well, I was wrong. For this use case, in this laptop, the H20 is a big upgrade over the H10. Well, for most people, I think it probably is. A laptop like this, for most people, is not a lean, mean, mobile multimedia machine. It's about productivity apps. It's about Microsoft Office. It's maybe some light programming, probably a lot of email. More email than any human being should really be forced to deal with, I think. So how much of a difference does the H20 make over normal NAND? Well, let me get logged in here and show you. Fresh reboot, totally normal. We're gonna launch 20 some applications at once. Oops. So that launched Microsoft Office, Excel, Word, PowerPoint, ATIS64, a couple of browsers, Stellaris, the character map, Paint, and about a dozen other programs that I could find. This is on a fresh reboot. Nothing has been cached into the 16 gigabytes of memory yet. Personally, I find that astonishing. Now, let's do that again, except this time, I'm pulling over a big file from a flash drive. All right, so while I have a write running on this, it's still almost as responsive. How is this even possible? Well, it turns out sequential read speed, which you see in a lot of benchmarks, doesn't really tell you a whole lot about how responsive the system is going to behave for interactive applications. I mean, if we look at Intel's own spec again, you know, it's like 40 to 50K IOPS. That's not an impressive number. And yet, here we are. Let's look at the benchmarks. Crystal Disk Mark. Well, I mean, you look at this and it's kind of pathetic. I mean, well, okay, it's middle of the road. I mean, the top line score here is only 2.9 gigabytes per second. This isn't even Intel's top rated speed of 3.3 gigabytes per second. I mean, on their own, these numbers are pretty weak sauce. I hate to say it, but it's true. But I would ask you to hold up before you pass judgment, because there's a lot more to the story here, as I found out. Intel says 3.3 gigabytes per second, as I've said. And I can match that, but only in very controlled circumstances. We've only got 32 gigabytes of cache, and it is managed fastidiously by RST, Intel's rapid storage technology. So you could expect that the speed, you know, for mere seconds at a time, in this case, best case scenario really is 3.3 gigabytes per second. And this is still better than you could do with NAND flash alone for this level of, you know, responsiveness. And really, that's pretty good. But hang on, that's faster than either half of this drive. Remember, I said that the H20 is effectively 2 PCI Express 3.0 by 2 devices on one M.2 carrier. So each half tops out at about 2 gigabytes per second. How are we at almost 3 gigabytes per second under most real-world scenarios and 3.3 gigabytes per second peak? The answer is in Intel's RST driver, Rapid Storage Technology. And this is actually a new version of the driver for the H20. So this is a pretty big upgrade over the H10, and we'll talk about that. And it is really magical. What about the latency in other applications, like PC Mark? There's definitely an anomaly there. Okay, let's look at it here. The H20 basically has best-in-class performance for real-world testing in PC Mark. Did Intel do something to the Underwriters Labs people for this test? No, they didn't. A score of about 3,000 for the quick system benchmark and a little over 500 megabytes per second for the full system disk storage benchmark is class leading. I mean, that performance is a little better than our Samsung 980 Pro, which is a 1 terabyte capacity. And the power usage here, the power usage is insane in the best possible way. I mean, our 980 Pro is pushing the limits of what you can actually do through an M.2 slot. It's supposed to be like 7.5, 8 watts top end, and that thing is like 10, 11 watts at times. Yeah, the H20, Intel claims 170 milliwatts. That's actually the mobile Mark 18 benchmark. I asked them about that. Real world, I was seeing about 5 watts, which is still pretty stellar for an SSD like this. 5 point something, give or take. That is phenomenal for a mobile SSD. I wouldn't want to put a 10 watt SSD in a laptop like this because it's a combination tablet. And yeah, background hum and normal usage, it is going to be sub 1 watt just about all of the time. The 170 milliwatts is a little more believable when we're not talking about like worst case scenario. But it's not in the worst case scenario power usage mode all the time. I mean, Intel's certainly done a lot of work around power management and the efficiency of the H20. You can clearly see that the drive is entering, high power and sleep mode really quickly, and there's not really a lot of overhead in switching between those modes, because if you come up with the right workload where the drive goes to sleep just at the wrong time, you can sort of see that in the performance benchmarks, and it's really hard to reproduce that on the H20. Oh, I tried. The Crystal Disk Mark doesn't tell you the story of Optane and what it can do for you the way that my ridiculous PowerShell script does, where it just launches a bunch of programs on fresh boot up, which again is admittedly not exactly a real world scenario, but probably the best way to show you how this can actually work. Sometimes I just want to grab the folks at Intel and shake them. It's like, do you realize how good this product is? Why? Why? I mean, yeah, the cost of Optane in the enterprise, I guess they do realize how good it is, because when you want to buy a lot of it, it's going to cost upwards, beyond $1,000 a terabyte. So a little bit of a price difference there. But what do we need to do to take advantage of it, beyond the laptop use case or beyond the office drone worker desktop use case? You might be looking for longingly at the subpar sequential read speed of the H20, but the standard issue office drone work, those transfer speeds don't help you. What matters is what the Optane H20 has in spades. What matters most in typical daily computing is how quickly you can service one read request, because it's typically read this, okay, I've got this, now this tells me where the next thing is, and the next thing, and so on and so forth. And that's why a low latency but fast enough platform is more important than the fastest platform, because the combination of latency and throughput is what your speed is. It's not just throughput, it's not just latency. Sometimes you hear that referred to in our reviews and other reviews as QDepth 1 or low QDepth tests. And the H20 result, well, it's incredible. No pure NAND SSD that I've tested so far can attain this level of performance unless you create a test that exceeds a 32 gigabyte, you're gonna overrun the 32 gigabyte cache, and then it's gonna average out in the longer term. But this usage pattern, everyday usage pattern, the H20 is basically in a class by itself, to the extent that I don't want a laptop that doesn't have at least H20 levels of performance, because the combination of low latency, even though for my stuff, I don't think 32 gigabytes is enough, and we'll talk about that. But for just, I need to deal with people and send emails and do stuff, this is pretty incredible. Now there is kind of a dark lining on the silver cloud that I've been hinting at this whole video. And that is a big piece of how Intel is doing this is through their driver, the Intel Rapid Storage Technology. It's not just a driver, it's actually some driver and some desktop software and some other stuff. We're at version 18 point something. And that means it's going to come from the Windows Store, at least the GUI for it, for managing your Optane and setting it up. The Windows Store on its own really leaves a lot to be desired. I don't think anybody would disagree with me. Leave a comment below if you think the Windows Store is completely and totally fine, because it's, yeah. So that means that RST version 18 functions differently than its predecessors. And we've had Optane and NAND, we had the H10, we had the DIY version where you could pick up one of these 32 gig, Optane disks and be able to deploy that and use it. Intel, I think, was thinking more about spinning Rust in the past than Optane plus NAND, and that's reflected in this new driver version. So if you're upgrading from one of those, you're probably okay, but a lot has changed under the hood in that software, it seems. And I think that those older configurations are operating in a different mode. For example, the software now calls the two different modes that it has performance and responsive. And pinning, which is what you used to have, where you could pin specific files to Optane and it would never evict them from the Optane cache. And that was actually good for things like Windows boot time. You don't have that anymore. That's not a thing. The RST software, when you're in the new mode, the better mode, doesn't give you the pinning option. And that's the one I recommend. It's actually better. It is actually legit better. So, super confusing. If you're in the position of having the old Optane and you need to go through the upgrade and get the Intel RST version, good luck. You're better off probably ejecting the Optane from your system and resetting it up from scratch. And I hate to say that because that seems annoying and dumb. And if you're an enterprise administrator and you deployed a fleet of Optane across your enterprise because you saw the value, you're also in for a bad time, and I'm sorry. Oh, if you're a crazy person, enthusiast, and you've used an 800 or a 900 series Optane desktop drive, heaven forbid, a server grade Optane, you're also in for a really bad time. This Optane SSD 9 280 gig seems positively Lilliputian in its capacity. And while it would work with old versions of the RST version, it now doesn't. And the new software will happily eject that. So it's not great. Let me explain. The old versions of RST unofficially supported bigger Optanes as a cache. If you're rocking one of these U.2 drives, or you got one of the enterprise cast-off M.2 drives, even like the 100 gig M.2 drives, which I think is a perfect size for the enthusiast cache, yeah, it's if you go to RST 18, you're gonna have a bad time, and it may take your data with it. I pointed this out to Intel, and they said they were aware of some of these issues, and their community forum is filled with lots of folks using Optane like this, because if you're gonna shell out for a 280 gig Optane SSD 9, chances are this isn't your primary disk only. You've probably got 4 or 8 terabytes of flash. I mean, I personally have big projects. I want more than 32 gigs of cache, but Intel isn't gonna give it to me, at least with RST. So, Intel also won't let me have it on Threadripper because there's no RST on Threadripper, no RST on Team Red. But it's really, there's a little bit of acceleration in the Intel CPU because they've got the whole VROC thing and that kind of stuff. So maybe that makes sense. But fortunately, you can approximate this level of bananas, 280 gig Optane plus 4 terabytes of flash, with Primo Cache. Yes, that actually works really, really well. I mean, I love Optane. How much do I love Optane? I bought this. I bought a P5800X Optane, which is the new PCI Express 4 one, with my own money. The problem strikes me as one of really just disorganization at Intel. It's another one of those, just shake them and try to get their attention things. If I were a CIO or a CTO at a big company and I were looking at an H20, I was evaluating it, I would probably insist on something like this for my office drones. Not just the laptop users, the desktop users as well. And office drones, I mean in the most endearing way possible, really. If it was an option, I would want every single regular desktop productivity worker to have this level of application acceleration. They're running a big Excel macro that has to scan a 35 megabyte file, or they has to do this or that or whatever with their system. It's gonna make it snappier and more responsive. I'm gonna have a more productive employee as a result. And there simply isn't anything in the middle. You get the H20 here, which is really awesome, and I can't say enough nice things about it. And then you've got, the 900p, which are harder and harder to find. Really, the 5800X is what you have at the top end, which is face melting. Beyond 32 gigabytes, 800 gigabytes, 1.6 terabytes, 2.5 million IOPS, but there's not really anything in the middle. And at the high end, Intel expects you to use this whole drive for all of your stuff, which really wastes an insane amount of Optane space. Most of the stuff that you would want to, go fast, you're never going to read from this thing. Look how effective 32 gigs of Optane cache is. 280 gigs as a cache against a 4 or 8 terabyte NAND pool is 1,000 times more effective than just laying out thousands of dollars per terabyte for an all Optane storage array. It just doesn't make sense. With having only Optane, just a few games, I mean, that's gosh darned expensive. And, well, you know, it's a little problematic. And for folks that are running that older Intel RST with a larger Optane, like the 800 or 900p, where it works, but it's unsupported, you're gonna have to be careful with that upgrade. You should also note that the H20 that I've got here in this laptop also popped into a desktop, a Z590, the ASRock Tai Chi desktop board, for what it's worth. As I said, no pure productivity system for an efficient office worker should be without one of these. And it worked. But again, that's another one of those, well, it works, but Intel hasn't qualified or tested it. So like the 900p, do you want to be off on your own in a couple of weeks or a couple of months or a couple of years when suddenly that's not a supported configuration anymore? It's like, oh, only certain laptops had that. No desktop had that. Let's just destroy your partition table. So in summation, the Intel H20. For what Intel intends to do with the H20, it is a home run, unabashedly, especially in laptops. This kind of a use case, this is a 4-core laptop, it's not an 8-core laptop, it's not a multimedia powerhouse. Goodness me, it is amazing. I really get that they don't want to offer this H20 as a retail product because they just don't want to deal with the headache of these crazies trying to rat rod their systems. I suppose that's what management must be thinking. People like me, it's like, no, it's just, you're trying to use that in a desktop system, you're trying to do something with it, you know, we don't want to commit the software resources to that. Seems very, you know, bean counter oriented. For productivity, there is the H20, not just for laptops, but I bet you that Dell or HP adds these as an option for their small form factor systems because it just makes sense in an office scenario. For face melting performance though, in your server, there is the P5800X, and that works fine on Team Red, as well as Team Blue. Oh, and I'll have a video on that P5800X I keep mentioning. I mean, 2.5 million IOPS is just way too face melting to let that go. And my goodness, it is an incredibly nice drive. I get the 800 gig version, and yeah, it is, it's something else. Primo cache plus a big NAND SSD plus a cast-off enterprise Optane, like the P4800X. Yeah, I mean, if I'm gonna DIY it, then so be it. I'm Wendell, this is Level 1. It's been a quick look, well, quasi deep dive on the H20. It's awesome, but there are caveats. I'm signing out. You can find me in the Level 1 forums if you have questions or you wanna learn more or do stuff with it. It's a pretty awesome little drive. Signing out. I'll see you there.